are starting this first panel today. My name is Clément, and I'm the CMO, of Aleph Cloud. Sorry, it's a bit noisy, so if you can join up or stay a bit quiet, thank you very much. And today, I'm super happy to host this panel with Markus Levin, is it correct? From XYO, Evgeny from Fluence, Sebastian from ICN, and Christian from Accurest. So this panel, as you can guess, is mostly about DePIN, and I would like you guys to very simply introduce yourself, what you do, and what kind of category does your company belong. So Markus, please, if you want to start.
Hi guys, I'm Markus. I'm one of the co-founders at XYO. We are the first and original DePIN. We launched in 2018. We started with proof of location. So we realized location gets easily spoofed to hack, right? You can download DePIN spoofing app and pretend that you are in Istanbul. Right now we're actually in Dubai. That's a problem for the economy of the future, but also for most apps on your phone. And we solved that through IoT devices and the network. And so we expanded on that and built now a data collection and verification and validation network. And you basically connect real-world data with blockchain. And also we provide proof of location to like DePINs, RWAs, and other things. We have more than 8 million nodes globally, and makes us also one of the largest DePINs and more revenues than Filecoin and audited financials, so we can prove it all as well.
Thank you, Markus. Evgeny, please.
Evgeny, co-founder of Fluence. At Fluence, we are building cloudless computing platform or decentralized computing platform, which essentially I explain usually as like Uber for compute or Airbnb for compute, which means that we aggregating compute power, like compute capacity hardware from multiple providers in many data centers in the world. And then we provide cloud services on top of it. And the main use case in Web3 is essentially we are providing infra for running nodes. Essentially, you can, every Web3 protocol has nodes. Nodes needs to run on some hardware on some servers. So we provide infra to run nodes. And we, lean towards AI as well and onboarding Web2 market because, cloud market is heavily about Web2 enterprises. They create like most of revenue for compute.
Thank you. Sebastian?
My name is Sebastian. I'm part of Impossible Cloud Network. We're close to 70 people. We have almost 5 million recurring revenue annually. And what we do is we build the foundational layer, what we call for the next-gen internet. What does it mean? We call this the evolution of the cloud. It's permissionless, truly open for everyone to contribute. What makes us different, I think, is that we come from the demand side. So we build the first product market fit, and we want to do a multi-service offering after our launch soon.
Thank you. And Christian, please.
Hey, everybody. Hope you can hear me. I'm Christian Killer. Don't worry about the name. It's not dangerous. Just a Swiss name. I previously have a PhD in blockchain voting and cryptography, and I realized for myself that a main issue we have is the infrastructure we run our protocols on. You can do a lot of cryptography, but at the end of the day, if the infrastructure is bogus, it doesn't help. So we are Accurest, the decentralized serverless cloud that is running on phones. We realized that phones have superior hardware. They're decentralized by design, secure by design. So, and also what differentiates us is that you actually can verify the compute that it actually exists because we bootstrap a trusted execution environment and you can check and also confidentially encrypt any compute and also verify whether it was executed on a specific device. I think this is the gist of it.
Okay, thank you very much. Before we start with the question, well, it's a question, but before we go deep down with the main topic, I just want you guys to the most simplest way, give me an answer to what is verified compute. What do you understand? What do you mean by verified compute? Markus?
Yeah, I'm not part of the cloud people here, but for me, verified compute is it's all in the name. It's the verification of compute power, and that it's trustless in a way.
Okay.
Yeah, actually, I realized that if you put headphones on, you can hear each other like good.
We need the headsets.
It's there.
Oh, okay.
If we can get it if you need it, because it's actually I can hear you well.
Or maybe we can increase the volume, or everybody can be a little quieter.
Anyway, compute verification means usually it's about execution, right? And the question came from when people started talking about blockchains, invented blockchain, and said, okay, we're gonna repeat the same computation on multiple machines, and we will do consensus on the computational result. We will call it verification, but you can do verification in a bunch of different ways. You can do with zero knowledge proofs. You can do with trusted execution environments. You can do with just a less resistant algorithms than modern consensus algorithms. And for example, in our network, what we also verify is the capacity, the compute capacity itself. Like whenever providers connect their hardware to a network, there's a cryptoeconomics algorithm that proves that they have these compute devices available and at certain performance. So this is also kind of verification. So yeah.
Okay. And please, sorry, Sebastian.
Same question?
Yeah, I just want you to because you are a cloud provider. I know we have two companies that are not cloud providers, but just how do you define the verified? I mean, how to verify computation, whether it is online or offline.
Yeah, I mean, we could go in on a technical level here, but I'm not sure it's relevant for everybody.
No.
I think at the end of the day, what people want when they use a service is to trust that service. That's what everybody wants. If you're a customer of whatever you buy something, you want to make sure that that is actually delivered to you properly, right? That's where I think the goal lies. Now, how you get there, I think, is different ways to achieve it. As mentioned, you could do a technical level, like ZK technology, for instance. There's other ones. At the end of the day, for us, how we resolve this is several elements. Should I touch upon these elements? Because you mentioned it's to keep it short. I'll try to keep it brief. So essentially, we do three things, right? So first of all, we are very picky with the hardware that we actually onboard. Why? Because we think that at least in the current stage, Web3 promises are not fully delivering on the vision yet, right? So what do I mean by this? We have enterprises using our services, and these enterprises rely when they store the data with us. They actually rely on us delivering certain SLAs, the typical Web2 KPIs, if you will. Now, how do we make that happen? We essentially have hardware providers in co-located data centers with said certification and SLAs, right? The second thing we do is we use typical collateral, if you will, which then gets slashed if you don't deliver that service. Then we have a third element, which actually puts transparency in all of that. We call these hypernodes, which essentially ensure that whatever service we promise to deliver is actually delivered. And with those three elements, we, at least for now, achieve set trust in the beginning that I mentioned. So again, where does the customer come from? They want to have that product or service delivered, and that's how we achieve that.
All right. And please, Markus. No, sorry, Christian.
Call me whatever you want.
Killer. Is it Killer fine?
It's fine. So I think I understood your point, but I'm going to disagree. Because I think the whole point of blockchains and DePINs originally was to be trustless, right? I know this word has been thrown around a lot, but at the end of the day, you want to build cryptographic systems that can be verified, right? Once you have this in place, you go down one layer and you find the infrastructure, and then you want to verify the infrastructure. Once you have reached that point, you basically can, the whole chain of interaction or transactions can be verified. And at this point, you have reached a trustless system that can be used by anyone permissionlessly, right? I think this is what verified compute is about. Doesn't matter how you implement it. I think on the technical side, ZKP is currently very complex, very hard to implement, not suitable for all the use cases. Trust executions environment, of course, you have the trust root of the hardware provider, but at the end of the day, it's the most pragmatic way that we choose as well to achieve a working system with what we have available on planet Earth. So I think I disagree. Of course, B2B speak, it means you have to trust the service, but I disagree on the technical side that it needs to be trustless at the end of the day, I think.
Yeah. Okay, so that sets the pace for my very first question then. What standards are emerging to validate the compute and data integrity in DP? You can't hear me. Okay. Yeah, I can repeat the question. Yes, what standards are emerging to validate compute and data integrity in DP networks?
You mean like formal standards or?
Yes, or new standard. It could be like, for example, the ZK-TEE. Which one between all of them might be the best? Because today everyone is rooting for its own services, whether it is MPC, whether it is TEE, whether it is ZK, etc., etc.
I think people throw around these terms a lot, like CKP, homomorphic encryption, MPC, whatever. But at the end of the day, it's an algorithm or a cryptographic protocol that has different parties, right? And depending on the context and the use case, a specific standard makes a lot of sense. So it would have to be boiled down to a specific interaction or context that we could really say one standard emerges. And in my opinion, also one of huge issue in ZKP right now, or in all these cryptographic algorithms, is that even if you have a new paper or an algorithm that supposedly should be a standard, it's all very novel. You might not have multiple implementations that you can cross-check. Even if you have one audit, if it's not formally verified, you just trust the code, right? So I think we're still very early to say that there's a standard way, except standard cryptographic primitives that we already have. I don't know, maybe somebody else has a different opinion on that. But
yeah, I think technologically, most of protocols in Web3 and DePIN right now just use TEE, like a trust distribution environment, because that's the easiest solution. You just take a piece of hardware, and it's sort of secure stuff. But the problem is it's still centralized, right? So there's a Intel or AMD who you trust, and they may sort of, if their key generation algorithm or key allocation algorithm is broken, then potentially what you run in there can be tempered. But overall, this is good enough solution. It even happens now in centralized clouds, for example. They build this product called confidential computing, which is essentially they run these devices, the servers. Yeah. And a lot of customers just want to switch from simple computing to confidential computing because they want more security around their data, like business operations and so on.
Yeah, there is a good comment. Sorry, Markus, you wanted to... Please.
Yeah, I think you have to look at data for broader side as well. It's not just the technical things, but a lot of DePIN data actually is not true, right? Because they incentivize to increase the number of data or transactions, right? Because that looks good, right? And that increases the value of the token. So I think it's important that data is validated and verified. And the way we do that, for example, is we have something called proof of origin, where we're able to say, okay, a data point was generated on a temperature sensor, let's say, and then saved into a ITFS database, and then put it into a smart contract, and we tangle it along the way, and are able to prove where the data came from. And for example, you realize that a lot of DePINs were off the coast of West Africa, in coordinate 00. They had like the weather stations or the other sensors. They were in the middle of the ocean. And I think we have to solve this, right, and to make DePIN and the data of DePIN trustworthy. We need to establish protocols to prove that the data is correct. Because if there's too much bad data, right, then the community will not trust DePIN, and that's bad all of it.
All right. I just wanted to bounce on your comment when you said that at some points using TE is centralized. You mentioned like NVIDIA, all the hardware components, but so far none of us here had the opportunity to use anything else. We still need to rely on this kind of hardware technology, right?
Yeah, we're still waiting for open source chips, TA chips. Still waiting. Please, someone build it.
Yeah, if someone is building that, you might have a lot of clients here. So we don't have a lot of time.
I mean, that's a global supply chain issue with TSMC and chip providers being super centralized. So at the end of the day, sorry to interrupt, but with phones, you can sort of mitigate this issue because you have different heterogeneous phones, right? Of course, the chipping side sometimes is homogeneous in terms of the provider. But at the end of the day, that's a bit how you can mitigate this issue, Alice.
Well, it works for certain use cases, but you still vast majority of compute and storage happens in the cloud somewhere where with a good connectivity, powerful servers. So like you cannot do everything.
I can also tackle that back because you can with USB-C achieve basically enough throughput if you daisy chain together a lot of phones to a cluster and then attach it to a fiber line, and you have a small data center. It's technically feasible.
I would love to see benchmarks.
Yeah, let's see in the next few months.
Okay. Let's circle back to the main topic. We don't have a lot of time, so I just like to talk about two things. The first one is regarding the tokenomics of DePIN. They're like different kind of tokenomics, but some might be more sustainable than others. And the other one is regarding AI storage, like all the products that
we view this is we have this built in economics. Maybe to also touch upon your second question is by having two components, right? So essentially we have a base reward, which anybody gets if they commit hardware to our network. And then number two is a dynamic reward for utilization. So what this does over time, it has a thriving ecosystem of valuable hardware commitments only, because customers will automatically only use over time in economical sense, that will only use those that are most according to the needs that they have, meaning only those will survive over time because they're going to get the best rewards out of the system.
I was just going to piggyback on the decentralized versus distributed part. I think distributed means you have one central authority that distributes something, and decentralized actually means you have N parties that have N different entities, right? So I think this is the main difference between having a distributed system and a decentralized system, in which is blockchain, what it's all about, right? So, and also on the other thing, I completely agree with the edge part. So that's one huge opportunity, especially now in the growing stage of DePIN, to sort of plug in there.
Yeah, I also agree locations matter a lot. So there's a bunch of use cases where the more locations you have, the better product or service we can provide, like gaming, video streaming, like all this, like video calls. Then also a higher cost efficiency. For example, in our case, we make sure that the protocol doesn't take margin, and then essentially customer get for the cloud, for the compute customer get the price, which is sort of for provider is like a 2-3 years break even for hardware. So it's makes the price really lowest across everything. Like it's lower than Hetzner, and Hetzner, if you know cloud business, it's like one of the cheapest cloud providers. So, and that's possible only with DePIN, because now you have this neutral blockchain managed by the DAO with no shareholders, no need to extract value for like those who hold equity in the company. And that's why you can really have efficient economics and provide best price. So DePIN did it.
Okay. So my very last question will be about sustainable tokenomics. We all run projects that rely on tokens that either pay for services or reward the stakers, the stakeholders, etc., etc. But I do think that, for example, the tokenomics for our token could be improved on different kind of levels. And I would like to ask each one of you what, and I think you all have probably different kind of answer to this question. What could be the most sustainable tokenomics regarding decentralized compute or DePIN in general? Because I know that not all of you are really into cloud computing. Markus?
Yeah, so I disagree with what Tom said earlier, that you should buy back and burn 100% of your tokens. I think sustainable economics also makes sure that your operations can run. Because if you use 100% of your revenue to burn, to buy and burn the tokens, then in the end you just rely on your token supply again, and the DePIN part becomes less relevant. And I think the great thing about DePIN is it has this longevity. As with us, we're around for 7 years, and we burned 86% of the total supply of the token over the time. So we burned a lot, but I don't think you should burn 100%. And I think it's important, of course, that in our case, for example, we have tokenomics where we have a buyback and burn component, and we have staking and slashing, and we're going to launch a new one later this quarter, and a new token, and there's lots of burning based on transactions and revenue and so on. But I think it's important also that your ecosystem and the company can thrive, and so that it not burn 100%.
Evgeny, I would add that important component in token economics is to have the utility for the token for wide amount of people to participate, and I feel that they are contributing somehow to your protocol by holding or a staking or doing something with the token. And that's important because you can build the tokenomics targeted for that would only be interesting for big funds. And that's fine, but then, all of this, if we speak about a crowdsourcing resources and all of this, projects that built around the narratives of collaboration and sort of sharing economies, which kind of DePIN is, it's important to have the involvement of, huge amount of people into the token economics.
Yeah, right.
Yeah, I think I mentioned a couple of aspects already. Maybe we're also providing a nuance that also we can have different views on this, right? So it depends on the perspective of where you're coming from. Maybe if we take a step back, it's not only about who you give the tokens out to, it's also, okay, how is the token coming in? Where's the buy pressure? Where is people actually buying the token, and not necessarily only for speculative purposes, but actually using the service, right? I think that's usually not the main aspect that's being looked at, but it's being overlooked, right? So that's why I think that, at least from our perspective, it's okay, how can we offer the best service to the customer that brings a lot of buy pressure? Then how you develop those tokens too, I think that's, there's different approaches to this. As mentioned before, we have this dynamic component, which over time incentivizes the best hardware to be on the network. And again, it's taking a step back, okay, where's the buy pressure coming from? That's also something that you should focus on in all of your tokenomics approach.
I completely agree. And I think the main goal should be in the beginning, especially to build a community that then contributes to the DAO, that then has the best interest of protocol in mind, so that you don't have to orchestrate everything centrally, right? So at the end of the day, I think this is the key thing, to have tokenomics evolving over time. And then doesn't matter the burn rate, it's really specific to the project, right?
Okay, this is a yes or no question before we go for the break. Do you think that, for example, your token, each one of you, could be replaced or used at the same time with a stable coin for the products, to pay for the products, for example? No.
We already have stablecoin. You pay with stablecoin for the cloud, and you stake FLT.
Okay.
To secure compute.
Markus?
I have to think about it.
I mean, the stable coins always play an important role, but replacing it, I mean, of course, you can just call it tokenomics at the end of the day, whether there's a token or not, but there's some mechanism needs to be there. No.
Okay. So we have one yes that it can be used with. I mean, not fully replaced. So we have one yes, no, and
maybe.
Okay. Thank you very much, gentlemen. It's a wrap, and it's time for the break. So thanks a lot. Et bon appétit, and see you later for the other talk. Thanks a lot. Thanks.